Thanks, Jeannie. Yeah, we're going to be talking about drilling plus the F word and earthquakes and the energy bill that we all face for gasoline or heating our houses. One thing to keep in mind is that one does not drill a fracking well. One drills a straight well, a vertical well from surface down to some sort of a depth, and that well might be later fracked, or you could drill a sidetrack bending out from the bottom of that hole and going horizontal for some distance, and then fracturing the shale or sandstone that horizontal well has drilled. In the past, oil was found seeping out of fractures in the Earth's surface. It was used by the ancients for anything lubricating chariot wheels, to Indians or Native Americans here in the United States used it to make waterproof vessels for food or water. There's nothing new about oil and its use by mankind. There were some embarrassing situations with people drilling water wells in the 1800s and coming up with a skim of oil or a big gush of gas when they were trying to drill a water well to get some water to drink. The first commercial well drilled in the United States specifically for finding oil was drilled by Colonel Drake in 1859. And that went to an astounding depth of 69.5 feet. Really a deep well. Why'd they drill it where it was drilled? It was drilled in a place called Oil Creek. And coincidentally, Oil Creek was named that because there's oil seeping out of the ground and there's a skim of oil on the surface there. People were skimming that oil and using it for liniment, for your sore elbows or other purposes, maybe even drinking it for medicinal purposes. But anyhow, Drake drilled this well, and he was able to get an oil flow from that well of about 10 to 20 barrels of oil per day. And that was a tremendous accomplishment, much better than the going out on the edge of the creek and trying to skim a little bit of oil out of the surface here and there. It turned into a great big boom of all sorts of oil wells being drilled, and they didn't have big fancy tanks. They flowed the oil into open tanks. Anybody wonder how many fires they had? That was just one heck of a big conflagration from time to time. Oil booms now don't quite look as bad to the visual senses as the old clustered derricks. We now have a pump jack which will occupy a surface space typically of well less than an acre, and the restoration of drill sites is now performed not only because of regulations but because of a little bit better ethics on the part of companies nowadays. They are still governed by regulations and forced to be sure that they do that sort of remediation. In the United States, in about the 1920s, we were ramping up production. By the time World War II came about, the United States supplied oil to a good bit of the effort fighting the war in Europe and the war in the Pacific. Production continued to climb until here in about the 1970s, when we hit something everybody called so-called peak oil. And people are now becoming afraid here in the 1970s, well, our production is going to fall off. What are we going to do? This is when prices were beginning to accelerate. The Gulf Arab states in 1973-74 had a freeze on selling oil to the United States. Production is now down in the 1990s to 2000. What can we do? Conventional oil wells are drilled with strings of pipe cemented into place to form a completely sealed system. Then the producing zone will have a device sent down on wireline where explosive charges or physical bullets shoot holes in the pipe to give gas or oil an opportunity to flow from the formation up into that well bore and up to the surface. It was found that fracturing those perforated intervals will increase the production anywhere from 10 or 20 times that production, all the way up to maybe 50 times the production. And that was first observed all the way back in 1865. Some of those early wells in Pennsylvania were struggling along at about 5 or 10, maybe 20 barrels of oil per day. And this retired Union Army officer had used high explosives in the Civil War, and he knew it made not only a big bang, but it broke rock apart. So he got the idea, let's go ahead and put what he called torpedoes down the well bores and detonate them, and let's see what it does. And it would fracture rock. It did not give very good control on it, though. But if high explosives worked, they decided, hey, nitroglycerin is some big bang stuff. Let's go ahead and try it. So they started using nitroglycerin. Here's a guy pouring nitroglycerin liquid into one of these torpedoes. There was a little difficulty with this. The roads back in those days were not super highways that are nice and smooth. They would have wagons carrying a couple of 100 gallons of nitroglycerin bouncing up and down on those roads, and occasionally the doggone things would blast. And it was a very hazardous situation. Nitroglycerin works. How about something even more powerful? This is an atomic bomb. In the 1960s and 70s, there were nuclear devices detonated, one of them in northern New Mexico, less than a mile deep, and it was twice the size of the bomb dropped on Hiroshima. That was used to make an attempt at fracturing some of the shales and sands. Here in Colorado, we had 2 devices set off in western Colorado. One at Rulison that was 3 times the power of the Hiroshima bomb. And then they tried to go even bigger, only slightly more than a mile deep, but it was 6 times the size of the bomb dropped on Hiroshima. Just huge devices. 15,000 tons of TNT was the Hiroshima bomb, so this would have been 6 times that. What is that, 90,000 tons of TNT equivalent. And they would get fractures that extended a few hundred feet out. Trouble is, they got a glassy rubble. It fused everything. In addition to fracturing, it kind of resealed many of those fractures, but they did get a gas production rate increase. That was the good news. The bad news is you couldn't use the gas. It had this stuff in it called tritium, which is a radioactive isotope of hydrogen, and it was just non-usable. So again, it's back to the drawing board. Company tested hydraulic-powered fracturing in Oklahoma and Kansas in the late 1940s with various wells. They were getting fractures that would extend maybe 100 feet or so, and they would use the hydraulic power pushed down the sealed system of multiple strings of drill pipe and use that to fracture the rock out away from the well bore. They tried to add certain amounts of sand to that fluid that was being pumped in to fracture. And the trouble is, if you try suspending sand in plain water, it just filters out pretty quickly. It falls to the bottom. So they had to gel that. They had to put additives in there to cause a very viscous fluid to be present. But they didn't want that fluid to stay viscous all the time. It needed to be pumped back out of the well and leave the sand behind in the fracture systems that it created. So they used gels that would be stable at normal temperatures as we have here. When they get pumped underground, the heat underground caused those gels to break down and turn back into a normal type fluid. That would leave the sand in the fractures, and they would recover that frac fluid back to the surface and allow gas or water to flow in. A little twist on vertical wells is, in many cases, wells were drilled, for example, offshore, where you couldn't drill a well every 500 feet or every 2,000 feet. You had to drill wells from platforms, and from a platform you would drill down for a little ways, then out at an angle, maybe a half mile to a couple of miles offset. And they would be drilled at maybe 50-degree angles or so, and could typically hit a very tight target, a target of about a quarter of an acre or less. And as we move into the 1980s, technology was getting better all the time. Gyroscopic control was better on these side tracking or horizontal drilling or diagonal drilling operations, to where they were able to get departures easily several hundred feet from vertical wells drilled out horizontally. And in the 1990s, these wells began to go out 1,000 feet to as much as a mile to 2 miles horizontally, and they would still stay within a single sandstone layer that was pretty thin. It might be only a 20-foot or 30-foot thick zone of sand about the height of your house, and they would stay within that zone for a mile or two out horizontally, and they would then, not fracking, but they would perforate, just shoot holes in the pipe that was cemented into place in that horizontal well. And the cost of those sidetrack operations for horizontal wells were going up to several $1 million. You could justify it when oil prices were up around $75 to $100 a barrel. Experiments were then beginning to be made with hydraulic fractures in the horizontal wells, but by this time over 1 million fracs have already been done, mostly in the vertical wells. So at this point in time, think about it, over 1 million wells fractured from 1940s to the 1990s. That goes a little bit counter to an argument that is posed by some people saying, well, we need to frack 1 or 2 more wells or another dozen or 2 dozen wells to see if it's going to cause a problem. These roughly 1 million fracks by that time had not caused any documented problems. People had wells for water source on their houses that would sometimes have natural gas in them. The pioneers had some of their wells with natural gas or oil skims in them. In many cases, or in most cases, those are near surface bacterially generated gas, and it makes a spectacular picture on a newsreel or a so-called documentary. But those instances have been investigated pretty carefully, and to my knowledge there have not been any that have been documented to be caused by oil and gas fracking operations. There were some that were caused by poor cement jobs and poor casing placement on vertical wells. There are some oil or other contamination that has occurred because of spills of fluid from your local gas station. But from fracking operations, none had been documented. And the EPA has just concluded a pretty widespread study. We're up to over 2 million fracks that have now been done. In the 1990s, a company in the Dallas-Fort Worth area started to drill some horizontal wells, and they decided to try fracturing some of the gassy shale. These were shales that were giving shows of gas when they drilled through them with a vertical well, but they would not produce a consistent amount of gas to make them worth completing. But this company called Mitchell tested longer horizontal departures out to a mile to 2 miles or so in length, and they tested by using more than one fracture job in each horizontal zone. They would perforate holes in the pipe, fracture that portion of the well bore, then seal it off with an assembly that could later be drilled out. They would then perforate some new holes and fracture that zone. And they were getting some pretty good results from that. They were testing new fluids for the frac jobs. And what happens then is you would drill a vertical well. You would then, from the bottom of it, sidetrack out. In other words, sidetracking is the operation of departing from vertical and moving towards a horizontal position. Then these wells would be fracked, not using nitroglycerin or nukes. Could you imagine the furor if they tried fracking a well in Boulder, Colorado, using a nuclear device? I'm not sure they would really go for that. Now, state-of-the-art as of 2017, horizontal wells are routinely being drilled 2 to 3 miles horizontally. If you sit and think about that, that's a tremendous departure underground. And this is at depths from the surface that range anywhere from 5,000 or 6,000 feet to as much as 10 to 15,000 feet in depth. Some wells have as many as 100 of these things they call stages. In other words, fracturing a portion of the well bore, temporarily sealing that off, fracturing another portion of it. They do that as many as 100 times. And another thing they're doing is drilling more than one well from the same surface site. They may drill a well that goes off in that direction, and all this is done with leases from all the property owners involved. Then they'll drill another well in this direction, another one over here. So by the time they have done that, they have one surface position that produces a number of wells that go out to the side, and there is not a need to drill from a number of surface sites causing surface disturbance, even if it's only an acre or so at a time. And there are moves to reformulate a good number of these frac fluids to become so biologically safe that they can actually be ingested. That's getting to a point where you need to be safe with fluids that are disposed of at the surface. That is one of the main hazards in my mind of a fracking operation or a drilling operation, the transport of fluids and materials at the surface. It's not the fracking operation underground, but it's transport on the highway. And we have, no matter what you do, you have accidents. We have 40,000 people, or over 40,000 people killed last year with normal highway accidents. There are trucks that are involved in highway accidents, whether they're carrying fracking fluids, diesel fuel, marshmallows, or Coors beer. That all happens. There can be surface storage failures. You can have Joe Blow working with a forklift, and in spite of all the caution labels, he backs a forklift into a storage tank, and you get a leak. So that's surface mechanical accidents. Anytime you have a drilling operation, you're going to have noise. For a drilling operation, you'll have noise for probably a period of anywhere from 2 or 3 days on the short side to several weeks on the long side. A hydraulic fracturing operation is going to take anywhere from a few days to a couple of weeks. And then after that, things get to be pretty quiet again. Those are the kind of the negatives that I see. Some of the positives: most companies now will monitor water wells that are in the vicinity anywhere from a radius of 1 mile to several miles radius, and they'll take samples of the water from those wells to be sure that everything is clean and proper with that well to start out with. That way, if there is a feeling from a property owner that their well has been contaminated by a drilling operation or a fracturing operation, you'll have a baseline to compare it to. And if they do find that there are materials in that water well that are equivalent to that used in the drilling operation or the fracturing operation, then it can be conclusively proved that that was the cause of their water well failure. We all know that living in this area, water wells occasionally tend to fail. They go dry, or the rates go way down, in spite of not having a fracturing operation next door to you. Those sort of things can happen. Fracks are usually anywhere from a few thousand to as much as 10 or 12,000 feet below any water zone. Those water zones are protected by multiple strings of drilling pipe. The first part of the hole is drilled perhaps 100 feet down, and they would set one string of very large diameter pipe, maybe 20 inches to 30 inches in diameter. That would then be cemented into place in the rock. They would drill out through that with a smaller size bit, drill down maybe 2,000 feet, set another string of pipe cemented clear back to the surface again to ensure that you have that protection for the first few thousand feet or few hundred feet of water zones. Potable or potable water zones, drinkable water, rarely extends more than a couple of thousand feet below the surface. In areas where it does occur deeper than that, additional strings of pipe will have to be run in place. Once a well is drilled down to its final depth, a completion, so-called completion string of pipe, a final protection pipe, is run all the way from the surface down to the bottom of that well bore and cemented into place. So by that time, you usually have 3 strings of pipe or more cemented to protect your water zones. Anytime people want to frack, they will try to avoid faults, because if you have faults, that fluid will bleed off quickly without fracturing the oil or gas potential zone. So they would be wasting effort. When they are pumping the fluid down hole, they're monitoring the pressure. If the pressure suddenly bleeds off, it means they may have gotten into a fault, and they immediately cease the pumping operation and seal off that portion of the well bore. And the other advantage of horizontal wells and fractured wells is you need fewer wells. One of the upshots, I had talked about the fracking of shale wells, which is a revolutionary new item. In the past, oil and gas was conventionally produced almost entirely from limestone sand reservoirs. Very few shale reservoirs were commercial. 1861, Colorado actually had shale production from natural vertical wells down near Pueblo. And there's still a little bit of production down there from those shales. When we start hearing word about earthquakes down in Oklahoma, it brings to mind the Denver Arsenal, which back in the 1960s decided that they needed to get rid of some of these waste materials from producing insecticides or poison gas. And they decided the best way to get rid of those was to pump them down deep into the basement rock, in other words, the crystalline rock, way below the depth of any zones for water or oil and gas operations. And it sure seemed like a good idea at the time, pump it down there about 10 or 12,000 feet. But all of a sudden they started getting some earthquakes, and there were some people that immediately said, hey, this seems to be too coincidental. Why don't we try shutting down, no waste injection? Let's see if this earthquake activity subsides, which it did. And they said, well, that's looking like good correlation. Let's double check. And they then let water go down just by gravity, by its own weight, seeping into those fractures down deep. And there was a slight increase in earthquakes. They went back with high pressure again, and boom, a lot of earthquakes. So they ceased doing that dumping of waste material. And I think the last decent-sized or noticeable earthquake in the Denver area was in the mid-'80s. But this illustrates that, yes, Virginia, if you pump fluid at high rates, high volumes, down into the basement rocks, you're going to lubricate the fractures that are already there. Those fractures would probably move in geologic time. They may break apart and have a little earthquake every 50 or 100 or a few hundred years. But by pumping that fluid down and lubricating them, you get a few centuries worth of earthquakes in a year or two. And that's just generally not desirable. Oklahoma noticed from just a handful of earthquakes prior to the 2000s, they were getting up to 100, 500, even 900 earthquakes per year taking place. And the earthquakes, by mapping out the points where those earthquakes occurred, they found that those were closely coincident to areas where wells were disposing of water produced from old reservoirs and some fracking water, but mostly produced water from old reservoirs. And they were pumping that down at higher and higher pressures all the time because the fields in Oklahoma were getting old. And as oil fields get old, they typically produce a higher and higher percentage of water. And that water has to go somewhere. When there were just small amounts of water, it could be injected back into the sides of the reservoirs that were actually producing the oil or gas, and it would help maintain the pressure. When they got so much water, they had to go deeper. And instead of producing to putting that produced water back into the edges of the reservoirs, they put it down into the basement rocks. And again, they're initiating the fracturing that would have taken place naturally, but over longer periods of time. And that fracturing is not directly associated with a fracking or hydraulic fracturing operation that might take place in a reservoir. This fracturing in the basement, or movement of fractures in the basement, movement of natural fractures, is caused by that produced water going in and lubricating the faults that are already there. We've had a number of price fluctuations. The Arab oil boycott we talked about. The high prices then caused a lot of drilling. That drilling caused prices to drop. Saudi Arabia decided to all of a sudden regain their market share, which flooded the market with oil, and the prices dropped dramatically. But here in the late 90s, early 2000s, you have industrialization that's taking place in China. Rapid industrialization in India and other countries. Everybody wants their motorbike if they had a bicycle. If they had a motorbike, they want to move to a small car. All of this is burning more and more energy, and as demand increases, the available daily supply was dropping. And then here in about 2000 to 2010, the effects of fracking began to be felt, and prices just dropped dramatically. So prices have, the lowering of prices caused by high amounts of production in the U.S. Caused the prices worldwide to drop. The slide I showed earlier about what do we do now, well, here's what fracking did. They brought us from about 5.5 million barrels a day production in the U.S. back up to nearly 10 million barrels a day of production in the U.S., almost equivalent to the best the U.S. has ever had. But one thing you will notice, production is now dropping off. The drop-off in oil prices has caused a lowering of the number of wells that are being drilled and hydraulically fractured. It's too expensive to spend $10 or $12 million drilling and fracturing a well if the oil price is down at $15 or $20 per barrel. The price has now gone back up to $40 or $50 dollars per barrel, and you're seeing an increase now again in the drilling and fracturing activity. We're probably going to see a sawtooth pattern here for a few years, but I think what hydraulic fracturing of shales has done to the United States and the world supply of oil is provided some sort of a buffer that's going to limit price increases due to the strong demand of oil throughout the world. We've seen that given a price of 50 to higher per barrel, it is economical to drill and hydraulically fracture these shale wells. And we can go to alternative energy sources, wind energy or photovoltaics or any of these sources. Each one is going to have its drawback. Wind energy has killed an unknown number of raptors. Quite a high number of raptors tend to get tangled up besides the sleighs and everything. But photovoltaics mandates a need for many of the so-called rare earth metals. And the reason they call them rare earth metals is there are not that many of them. There's not a huge volume of the rare earth materials around that are needed for photovoltaic and other renewable energy sources. We're going to have to move away ultimately from oil and gas. There's no doubt about that. But we need something in the interim during this transition period. And oil and gas seem to be the way to accomplish this. The great amount of fracturing of natural gas prone shale in the United States has enabled gas prices to drop from about $14 per thousand cubic feet of gas to a level of about $2.50 or $3 per thousand cubic feet. That's about a quarter of the price. And the consequence of that is that we're replacing coal with natural gas, and the United States has accomplished more of a drop of greenhouse gas emissions than any other country in the world. by substituting that natural gas for coal. That's part of the transition to more more environmentally favorable outcomes with energy. But ultimately, we're going to have to move to wind energy as a greater use, tidal energy, taking advantage of the fluctuations of sea level to generate electric power. And we're all going to have to be more tolerant of large, high-powered transmission lines going around throughout the country. There's always a reluctance to see new power lines built across environmentally sensitive or beautiful areas. But the western part of the United States has intense sunshine, many clear days. There's going to have to be power lines built across the western U.S. But any energy source is going to have its drawbacks. So that concludes my comments right now. My background, personal finances have been adversely impacted by fracturing, hydraulic fracturing. I do own an interest in oil and gas properties. They're conventional properties. So the lowering of prices has hurt me, but I think overall hydraulic fracturing has been a strong benefit to the United States economy. There have been a lot of scare tactics, I would call them, about fracking, and the vast majority of those, I think, are greatly overstated, if not fabricated. I am not aware of documented cases of fracking itself causing pollution or contamination. Yeah, the energy industry is probably one of the more highly regulated, more intensely regulated industries in the United States. And very frankly, there are a lot of bad screw-ups that were made by the industry in the past. The industry would dump salt water on the surface, either accidentally or intentionally, and just let it go. That kind of behavior just does not occur, is not tolerated anymore. On a fracking operation or a drilling operation, if you spill a couple of quarts of motor oil, it requires a pile of paperwork to explain it and a lot of remediation to clean that up. The most expensive barrel of oil in the United States is a barrel that's spilled or contaminates a property. You can sell oil for about $40 to $60 now. If you spill it, it's going to cost you a few $1,000s a barrel at least to clean it up. Yeah, in the back.
John, I just read about a company that is experimenting with using targeted microwave to accomplish fracking. Have you heard anything about that?
No, I haven't, but there's a lot of experimental techniques that are being tried, including nuclear devices. Microwave devices may work. I'm not sure if they will have the energy necessary to get 100 feet or several hundred feet from the wellbore. Again, these fractures that are manufactured by hydraulic pressure extend distances anywhere from 100 feet to 600 or 800 feet laterally, but only about 50 to 100 or so feet in a vertical sense. They much have a greater preference for moving horizontally within a formation. And microwave, you need a tremendous source of electrical energy down hole, and who knows? It may work. Yeah.
I know you're not a nuclear engineer, but I've seen and read recently about a lot of new developments in nuclear energy, and I wonder if you have any insight to when and if that might be a viable alternative to
There are
products.
Coincidentally, our son is a nuclear engineer.
Oh, well, maybe you should come to the next Chautauqua.
Yeah. Nuclear presently produces about 30% of the electrical energy in the United States. And I don't believe we've had a new nuclear facility since the 1970s. There have been a couple of additions to existing facilities that are in the mill. But they're looking at additional ways to utilize nuclear waste, which is being done by some of the reactors in Europe, so that by the time that operation is done, you have virtually no nuclear material that is dangerous that has to be disposed of. Everything is utilized. It's almost like making sausage, but it's nuclear sausage. You're using everything. And the United States has not gone to that, primarily for the reason that the testing in the United States has not been done on those types of reactors. And the Nuclear Regulatory Authority is extremely nervous about anything different. I was able to have a tour of my son's generating facility, and the layers of protective devices, one upon another, just piles of protective devices, are amazing. And ultimately, I think we're going to have to go to some more sophisticated reactors, though.
Either one of the owners of Microsoft or Apple, I don't remember which one, is involved in one of those reactors that's going to be using the already processed nuclear waste. They're testing it in China because they can get away with it in China because they don't have our regulations. So a lot of the theories are still being worked out, but it's being done in China.
Yeah, France had reactors of this sort utilizing their so-called waste material, making nuclear sausage using every bit of the energy extracted from the material. So it's not a revolutionary technique, but it's new to the regulatory authorities in the United States. The U.S. regulatory authorities are just super, super careful.
John, getting back to oil, a lot of people don't know that an oil well produces much more salt water or brine than it does oil, and that salt water has to be separated from the oil product. What are the trends in disposing of that secondary material, the brine and salt water?
Yeah, that's a good point. An oil reservoir will often produce mostly clean, so-called clean oil at the very first stages. But what we're faced with in Oklahoma and other areas is, through time, the percentage of oil in the volume of water, of material removed from the well, diminishes. The percentage of water creeps up until toward the end you're up to 95, 99, or even 99.5% water. Some of the old ways of getting rid of that water, number one, it would be put in open pits at the surface and evaporated. That works if you have a small volume of water. The most common feature that was done to get rid of the water in the past was drilling a water disposal well off the side of the structure that produced the oil, and that water would be injected back into the same reservoir. The concept there is oil and gas are lighter than water. If they're in a trap, which is, think of it as almost a piece of plastic you put on a swimming pool, you get under there and blow bubbles. The bubbles will stay against that piece of plastic floating on the water. And that happens in a reservoir, but you can pump that water back into the edges of the reservoir, and it helps keep the pressure up for producing the oil or gas. That works for fairly large volumes of water, but now in states such as Oklahoma and certain localities around the rest of the U.S., the volumes of water from the older fields combined with another couple of percent of water from frack jobs the wastewater from fracture jobs, that was getting so much that they could not put it all into the edges of those reservoirs, so they went towards pumping it into the basement. And the basement rocks are granites or metamorphic rocks such as we have here with the Pikes Peak granite, the pink granite around here, or the metamorphic rocks such as over in Badger Flats outside of Lake George. But those occur deep underneath the sedimentary layers in eastern Colorado or over in Kansas or Oklahoma, and they have natural fractures. So that's the reason why wells have been drilled down to those zones, and larger volumes of water could be put away, pumped into those zones. But we see that what that's doing in certain areas, it seems to be lubricating existing fractures and faults underground. So you're getting several years or even several centuries worth of earthquakes in just 1 year. And they're looking at some methods potentially of reverse osmosis to treat the water. That gets expensive, but if the expenses of otherwise handling the water go up, then reverse osmosis or some other treatment like that, distillation may become economical. But there's a lot of work being done on it now. See.
Do you want to comment on the long-term prognosis or future of coal?
It all depends on what is going to happen with the feeling that people have toward greenhouse gas.
Well, I mean,
Burning.
more from the economic perspective, because power plants that are coal-fired or the natural gas-fired. So I meant more from, not feeling, but from just the practical side, production, cost.
Well, that's going to be dictated by the environmental regulations. And now we're seeing many of the coal-fired plants that are being mandated to move over toward being natural gas-fired. There are some ways that are being experimented on for removal of CO2 from the smokestacks. That looks real neat on paper, but nobody's gotten it to work on a bigger scale basis yet. It's a very complex situation. There's some thought about just compressing the effluent from smokestacks and injecting it into the ground. That can have its own side effects, as we see from pumping salt water down into the basement. Not sure what it's going to do. If you don't pump it down deep enough in the water zones near the surface, for the first few thousand feet, there are fracture zones that do communicate to the surface. Coal, they may move towards doing some processes of coking it that would remove some of the more dangerous elements to it. But I would suspect the coal industry is going to be hurt pretty severely over the near term. So
Well, I was just going to comment, we had done some experimental stuff in North Dakota with recapturing used well water that was pumped downhole. And we were able, and I don't know the cost, I wasn't tied up with that part of it, but we were able to recapture about 50%. We were able to recapture about 50% of the water. Mm-hmm. You could drink it.
Okay. Yeah.
For fracking, what kind of fluids are you fracking with, or can you enhance that with certain chemicals that make it more efficient? Those chemicals do.
The fluid that's used for a frac is typically 98, 99% or more just plain old water. And then there is a content of sand that is in suspension, and the water has added to it various chemicals. It will have chemicals to increase the viscosity, make it more of a jelly-like material to keep the sand in suspension. And then they typically also include biocides, something as simple as a chlorine compound, or sometimes more complex chemicals. The reason for that is when you use surface water and pump it down hole, bacteria from the surface will contaminate the oil and gas zones, and the bacteria will start eating the oil, removing the more volatile components and leaving a very asphaltic, gummy residue near the wellbore where that bacterial activity is taking place. So that's the reason for adding some of the biocides, which are typically the more dangerous components of a frac job. The other components are material we use around the house all the time. Table salt, various soaps, and believe it or not, the EPA actually characterizes pure sand as being an environmental contaminant, a dangerous material. And I guess if you start eating sand, it is dangerous to you. Water itself is dangerous. You can poison yourself with too much water. But many of the companies are experimenting with trying to get their frac fluids, the material used for a frac, as environmentally friendly as they can, so that if there is a spill at the surface, they're not going to incur as much in the way of cleanup cost or liability. They still would have to clean it up, but if you spill sugar on the ground, you have to clean it up. If you have a tanker of molasses that bursts and you have 8,000 gallons of molasses on the street, you're going to have a heck of a cleanup job to do. Molasses, a teaspoon at a time, is not hazardous. But nobody wants 8,000 gallons in front of their house.
Yeah, but hydrous oxide is not too hazardous.
No,
H2O is not too hazardous.
no, not unless you have to really go out of your way to drink enough to be poisonous. But they're looking at trying to reuse as much of this frac water as possible. There is a concern that many people exhibit, a concern that, well, if we're using a few million gallons of water on frac jobs over in Longmont area, then God, that's several million gallons of water. We're going to run out of water. The fracs in Colorado use less than 0.5% of the water used in the state of Colorado. And that's at the peak of drilling and fracking activity a couple of years back. It's less than that now. Agricultural use and people in the big city watering their lawns account for a humongous volume of water contrasted with the relatively small percentage of less than 1% used in fracs. Question in the back?
So if fracking's been around for so many years, why are we just now hearing about it like it's something that's brand new?
It is brand new to many of the people in the media, and my personal opinion is that there are some people that feel so strongly about their environmental causes that they will grasp at anything they can use to advance that sometimes overly intense environmental emphasis. And most of us here, myself, I enjoy the outdoors. I love the outdoors. I don't go dumping gasoline around on the ground. I don't dump contaminants around. I don't think many of the other people do intentionally. Most of the people with drilling operations or fracking operations are normal people. They're not going to go dumping material on the ground. As I mentioned earlier, the most expensive barrel of oil is the one that gets spilled. That's several $1,000s a barrel. Maybe.
I'm really glad I came to listen to this today because most of my family's in the oil business. I've never heard them talk about fracking ever.
Now, there's another gentleman here today who's a retired professional in the field. I don't know if you have any other comments you want to make, Jerry?
Well, just, I think somebody said it, there's so much misinformation out there, and a speech such as yours is, again, I applaud you for laying out the facts, because it's like X-Files, the truth is out there somewhere.
Yeah, it's not to say that at some point in time somebody is going to have a fracking operation that somehow does cause contamination. Anything can happen. Given the now over 2 million frack jobs that have taken place in the United States. And there have been some people exhibiting concerns in the state of Colorado or in some of the municipalities that, hey, we need to sit back and study this. We need to figure out what's going on with fracking. Is it really dangerous? And we need to see the operations from another dozen or another 50 or so frack jobs. With the 2 million or more that have been done already, I'm not sure of the increase to the database that will come about through a few dozen to even a few hundred individual case studies. The EPA just is wrapping up, I believe it was a 2 to 3 year study that they've done on impacts of fracking and just trying to research the areas where people have their ignitable faucets and so forth. And they found that those are natural contamination from bacterial action working on peat and other woody material in the near surface. There are some areas where hydrocarbons, oil or gas, are being generated at depth and coming up to the surface. Colonel Drake knew that when he drilled his well next to Oil Creek. That's where the oil was seeping out, that when you go looking for acorns, you go underneath an oak tree. If you go looking for oil, you try drilling a well near where it's seeping out of the ground. Okay, any other questions? Yeah.
What are the mechanics transition? What do they use to guide that?
Sometimes they use an assembly called a whipstock, which is, think of it as a wedge that you put at the bottom of the well, and you push your pipe upon it, and it forces it to go off in a direction. And then after that point, the drill assembly is guided with gyroscopic control. You can't use a satellite or anything underground, but the gyroscopic control gives extreme precision. You can hit a target the size of this building at a distance of 2-3 miles or so, drilling horizontally. And horizontal drilling is now being used to put telephone lines or fiber optic lines underneath highways, instead of digging up the highway, having a trench that continually collapses on them. They just drill a short hole underneath the road. They control it pretty carefully.
Some of the wells we've had in Teller County that have lost, water wells, that have lost production or become dry, they actually, before I got involved, you could put high air pressure down those and frack those wells to improve the production of the water well. And you don't have to put fluids down, it's just done in air. And maybe just pure water.
Mm-hmm. Yeah, hydrofracking of water wells is another technique that is being used. Here in this area, our water doesn't come from an underground river. There's not such a thing. If you drive along the highway, you'll notice all these rocks around here have cracks out the wazoo. There are cracks everywhere. And there's a certain number of those cracks that are also underground. Those are filled with water, and that's our water reservoir for this area. If you are unfortunate enough to drill a well in a spot that is not highly fractured, by using hydrofracking of your water well, you may be able to make more cracks there that will communicate with some of the other cracks that are loaded with water. And that can often give a benefit to your water well. And typically with those, since it is going to be drinking water, they would use very carefully chosen ingredients to their frac material, frac fluid. Any other questions? I've got a diagram up here on the wall that you're welcome to come up here and take a look at. It's a little Mickey Mouse diagram where I've got a house up here and everything is to scale. But there's this little 30-foot tall house and a water well with water zones here down to about 800 or 900 feet. And then the fracs take place down here in this 3,000-foot horizontal zone. And the fracs extend up maybe 50 to 100 feet, but it's still almost a couple of miles from many of the water zones. And that's a saving grace why water wells are usually extremely safe for many of these operations. And there are coincidental losses of productivity of a water well that sometimes occurs even though the closest frac operation is 50 miles away. But most operators of these activities now monitor the water wells around them just to make sure there's no contamination. Or if there is contamination, they'll know that there was and it's not a fabricated situation. Okay, thank you very much.